Good evening, or good afternoon, or good morning, whatever time of day it is. We're going to do section 1.4, and we're just literally going to translate phrases into expressions. That's all we're going to look at. So we're looking at phrases, certain words or certain phrases that you need to look at that indicates a specific function. So, um, so the first thing we want to look at is that if you have to solve a word problem, you must translate the words and phrases into expressions and equations. So let's get the expressions down first. Okay, so let's look at some of these here. Anytime you see like for you see like addition here. I've got addition, and we're looking at the word sum of. That's pretty common. And then you see sum of or some, like here I've got the difference between, and then you look for the word and. Okay? So like here, the sum of 8 and x, that is where your plus sign goes. So what's before the plus sign goes, the 8 goes before, the x goes after. So it translates 8 plus x. A number, so we got a number, say n, increased by 7. Increased, meaning we're going up. So going up means you're adding. So we're saying 8, so a number, n, could be x, could be y, could be q plus 7. 5 more than. This one you're going to reverse them. Okay? So these are almost always reversed. Anytime you see like more than or less than, they're always going the number's going to be reversed. So this goes after the sign. So more than, I got italicized here, is always your plus. So you can reverse the order. 5 plus n plus 5. Here's some other ones. The difference between a number, there's the prepositional phrase, there's the preposition between, and there's your plus sign. So that's where your plus sign will always go. A number and 4x minus 4. Excuse me, that's not a plus sign. That should be a minus. What is wrong with me tonight? A number decreased by 8. So we're going to decrease. That's our function. So we're going to lower a number x minus 8. That one pretty much do it in order. This one is another one we don't do in order. This one we're going to reverse it. Less than or more than, it's in reverse order. So this one, the 5, will go after. So this is where my minus sign is, but the 5 is going to go after, and the number is going to go before. So that would be n minus 5. 6 minus the number, that's just straight across. Minus, right there. The product of, and. For and a number. For n. 4 goes before the times. And if you got to, and anytime you're doing multiplication with just a number and a letter, you just match the number and the letter together. So 7 times a number, 7 times, there's your times symbol, 7 times a number, so that ends up, 7n. I've got 7y here, same thing. 1/3 of. So if the number before the of, if you see the of between, like usually it's a fractional number. So if the number is a percent or it is a fraction, you can use just of, and that word of means multiply. So 1/3 of, that means 1/3 times a number, or 1/3 x. Another way we'll learn later is that x can just come up here, and you could write it as x over 3. Either way would be fine. The quotient of, there's my fraction bar, or I could have wrote it, a number, b divided by 8. But generally when we deal with division, we'll use the fraction bar. A number divided by 10, m divided by 10. So there's a lot of things that we can look at when we start looking at expressions. So let's look at a couple examples here. We want to do example 1. We'll do this real quick. 3 less than. Remember, less than and more than, that's the reverse ones. So I know it's a minus. I know my 3 is going to go after the symbol. So I put my 3 here. The x must go before. So that's x minus 3. 2 is going to be a little bit harder. So we'll go ahead and see if you can figure that one out. Take about a minute, see if you can. Pause it, and I'll see you in a minute. Okay, welcome back. It says half the difference between x and 3. So let's look at this one. Half. So let's deal with this one first. I don't want to deal with the half yet. Half we know is a fraction, 1/2. Half the difference. Anytime you see like a fraction or twice or triple the something, that implies multiplication. So you're going to do multiplication with parentheses. So inside the parentheses, we got the difference between, or I would use like the difference, you might say the difference of, and there's my and, my minus 3x. Half the difference between x and 3. 1/2 x minus 3. So example 3 here, see if you can try this one. A little bit different, a little bit easier. So take about 30 seconds to a minute. I'm going to pause the video, try these 2 little blanks, and we'll see if we get them right. Okay, welcome back. It says if the board is length L, the length of the board is 7 centimeters shorter. Here's another one that's reversed. Shorter. That means we're making it smaller. So if it's getting smaller, we need a minus sign. And this is just like less than or more than. We want to reverse it. So 7 is going to go after the minus sign. So it's going to be minus 7. But what are we subtracting 7 from? The length of a board. So we're going to start with the length of the board, L. So it's L minus 7. Again, the length of the board on this one is 6 centimeters longer. Longer means plus. The 6 is going to go after. So it is L plus 6. And if you notice, I use a cursive L because that way you know that it is an L and you can't tell if it's an L1 or whatever. Just so we're on the same page. On this one, a formula is an equation that explains the relationship between different types of numbers. Here are some common ones that you'll see. You got the first one. The first one's the area formula. It's area of a rectangle. Area is length times width, or A equals LW. You say L times W, you see LW, and we say length times width. We know that is an L and W. Perimeter is twice the length plus twice the width. So we got 2 times the length, 2 times the width. Distance equals rate times the time traveled. And now they have to be in the same time units. So just remember that the rate, remember if it's in miles per hour, your time is also an hour. So just be reminded of that. C equals NP. Cost equals the number of items per price of the item. So these are just kind of, these all make sense. Okay. So let's look at this one. Example 4. I'll do this one. I'll let you take a second on 5. It says find the area and perimeter of a rectangle of length 10 and width W. So let's go ahead. We know that the length, so we know that L equals 10. So let's find the area first. Area equals length, which is 10, times the width, W. A equals 10W. There's our formula. Now the perimeter might have an extra step or two. Let's just look at it. So I've got 2 times the length, which we know is 10, plus 2w. But what is 2 times 10? Well, that one we know is 20 plus 2w. And there is the formula for the perimeter. So pause, try example 5, and we'll come back together. Okay, let's welcome back. So we've got a couple things here. It says, I've got you and your friends, you buy 2 pizzas at P dollars and the 4 salads at S dollars each. So what's the cost of the pizzas? Let's look at the cost of the pizzas. We look at this the cost formula is number of items. So how many items did I buy? I bought 2 pizzas at P dollars. So that's how much they cost times the price per item, or 2p. And sometimes you want to look at this word and here. So if you're doing like using multiple formulas and you got an and there, generally, not always, but generally you might want to look at an addition. Because if you're buying all of those things together and you want to get a total price, then, or a total cost, then you look at, we got to do an addition here. So this one is, we're going to add to it the cost of the salads. Well, again, we know what the cost of the salads is, the number of salads times the cost of the salads, or the price per salads. We know the number of salads we bought was 4. And the cost of each salad is S. That is going to equal the cost, or how much we spent, the total cost. It's kind of like when you go to the store and you buy 3 Mountain Dews and 2 bags of chips. Boy, you don't just, you total up the amount of Mountain Dews you bought and you total up the amount of chips you bought and you add them together. Same thing here, okay? It's just like going to a restaurant and you order all this stuff. So let's go to the next page, last one. It says if you travel H plus 1/2 hours at 80 kilometers per hour, how far do you travel? So we know that our distance equals rate times time. I know this. Anytime you see this hours, we know it is a time. You see something per hour, I know it is the rate. So my rate is 80. My time is H plus 1/2. So D equals 80 times H plus 1/2. Oh, wow. What do I do with this one? This one, we're just going to leave it alone because some of you might want to move the next step, but we don't have to at this point. But I will go ahead and tell you that we can. But this one, we're not going to do any distribution or anything. We're just going to leave it like this. So this one's pretty straightforward. So if you got a parentheses one, kind of leave it alone for right now, and we'll come back to that one. This is Mr. Benning signing off.